Hi everybody. In this section we're going to be looking at how we can use an equation to calculate speed of an object. Before we were doing graphing, but now we can do an equation. So the definition of speed, and we talked about this in class, is how far an object goes in a certain time, or the distance an object travels in a given time. So if I'm traveling 80 kilometers an hour, I travel 80 kilometers in 1 hour. That distance in this time. Now, my equation is equal to speed is equal to distance over time. And you should look at the change in distance, change in time. So I use the symbol V for speed, D for distance, and T for time. This little triangle symbol just means change. So my speed is equal to the change in distance over the change in time. And I'm just going to use this little formula triangle to help us out. So again, the D is the distance. We measure it in meters or kilometers. Speed, we can measure in kilometers per hour or meters per second in our class. And time can be measured in seconds or hours. Now, the way the formula triangle works is if you're over something like d over v or d over t, you're dividing. If you're side by side, you multiply. So according to this triangle, if I want to figure out my speed, I put my finger on the v, and my speed is equal to d over t. That's what I have over here. If I want to figure out what d is, the distance, it's on top, so it equals v times t. And that's what I have over here. And finally, if I want to figure out the time is equal to d over v. D over v. So those are the equations we're going to be using. Now, when we're doing problems, we're going to be using the GRASP or GRASS method. You've done this before in grade 9, probably in grade 10. So the G is what you're given in the problem. The R is what you are trying to find, the required. Analysis just means you're doing some thinking, you're figuring out the equation. Substitute, you plug the numbers in. And in your statement, you just write down the final answer in the form of a statement. So let's look at an example. So I'm going from Windsor, or Mississauga to Windsor. It's about 380 kilometers. The kilometers means it's probably a distance. And it takes 3.5 hours, so that's my time. And I want to know the average speed for the trip. So I know my givens, I write them down. My distance is 380. My time was 3.5 hours. I'm going to use my formula symbols, you notice. And I'm trying to figure out speed. So I'm going to put down V equals question mark. That's what I'm trying to find. So I'm going to use my equation, go up here. So speed is equal to distance over time. Write that down. And then I'm going to simply plug numbers in here. So I know my distance is 380. My time is 3.5. And then go 380 divided by 3.5 gives me around 109. And the units are kilometers per hour. That's the speed unit. And I just write this down as a statement. So therefore, the average speed is 109 kilometers an hour. Here's another example. How long does it take a car traveling at 120 kilometers an hour to travel 335 kilometers to Ottawa? So I've got a speed over here because it's kilometers per hour. It's 120. I put that in my given. My distance is 335 kilometers. That's my distance, my givens. And I'm trying to find my time, the length of time it takes. So look at my equation. So my time is equal to distance over velocity. Plug my numbers in. So distance is 335. My velocity, or speed, sorry, is 120. And when I calculate it, gives me 2.8. Now, you got to do some thinking here. The kilometers cancel, you end up with hours. That's a time unit. So therefore, it takes 2.8 hours to drive to Ottawa. A little statement. Just keep it nice and short and sweet. And when you're doing these problems, try to keep the units consistent. So always have kilometers, hours, or meters and seconds. Try to group them. So here's an example. We've got meters per second. So I'm trying to figure out how far the toy moves. That's my required. If it's traveling at 3.5 meters per second, that's a speed unit, in 45 seconds. That's going to be my time. So my equation, going back up, I'm trying to find my distance. So it's equal to speed times your time. And there's my equation. So I plug numbers in here. So my speed is 3.5 meters per second. The time is 45 seconds. You multiply through, and you end up with 158. Now, the unit's going to be meters because the seconds cancel out over here. So therefore, the car travels 158 meters. And we're done. So those are some great examples. So again, use the GRASS method. So write down your givens, what you're trying to find, the required, the equation and the analysis, substitute the numbers in, and have your statement at the end. And you're in business. Now, sometimes what we want to do is we want to change our units. So most of the time we've got, in real world, we've got kilometers an hour, but in physics, we've got meters per second. So I got to be able to switch back and forth between them. So we use this magic number, 3.6. So if I'm going from kilometers an hour to meters per second, what I'm going to do is I'm going to divide by 3.6. That's what this little symbol is. Messed up, but still. If I'm going the other way, I'm going to be multiplying by 3.6. So if I'm going from meters per second to kilometers per hour. So here's an example. 75 kilometers an hour. If I'm changing to meters per second, so I'm going from here to here, you divide by 3.6. So 75 divided by 3.6 gives me 21 meters per second. And that's it. How about this one? What if I have meters per second? I want to go kilometers an hour. Well, you go the other way. You multiply by 3.6. We end up here with 3.6 times 2, or 7.2 kilometers an hour. What you should remember is that meters per second is always a small measurement. It's always smaller than kilometers an hour. Kilometers an hour is bigger than this. So if I want to go from kilometers to meters, I have to get smaller. I'm dividing. If I'm going meters per second to kilometers an hour, I have to get bigger, so I have to multiply. So just think of it like that. So again, the big thing here is try to remember that meters per second is a smaller unit, and kilometers per hour is going to be always a larger unit. And that will help you figure out which way to go. So if I want to go from larger to smaller, I got to divide. Smaller to larger, I have to multiply. And then we just do a little bit of practice down here just to make sure that we're okay with these skills. So try those out, have a little bit of fun, and then work on the speed calculation worksheet. I've got the answers posted online.